Welcome to The Explainer. Today, we are diving deep into a technology that could, completely change the game for how you manage massive, and I mean massive amounts of data. We're talking about the Resilient File System, or REFs, and how it's getting supercharged in Windows Server 2025. But before we get into the nuts and bolts, let's just start with a really big question. Our data is growing bigger and moving faster than ever before. So are the tools we've been relying on for decades, like the good old trusty NTFS file system, are they still truly up to the job? Okay, so here's the plan. First, we're going to look at the problem, the modern data challenge. Then we'll introduce the solution, REFs. After that, we'll break down its powerhouse features, see exactly where it shines, and then, super important, we'll finish up with a reality check on its limitations.
Right. First things first, let's set the stage. To really get why REFS is such a big deal, we need to understand the core challenge that's facing pretty much every modern IT infrastructure today.
It really just boils down to this. The sheer volume and speed of data pouring in from virtual machines, from huge backups, from complex analytics, it's pushing these older systems right to their breaking point. And we're not just talking about things getting a little slow. We're talking about the very real risk of data corruption and some seriously costly downtime.
Okay, so that's the problem. What's the solution? Let's take a look at Microsoft's answer to this whole challenge. A file system that was built from the ground up specifically for this new era of data. Look, REFS is not just a simple update to NTFS. It's not NTFS 2.0. It is a complete and total rethinking of how a file system should handle and protect data in these high-performance, high-stakes environments we all live in now. The keywords to remember here are availability, integrity, and scale.
So what's the magic here? What really makes REFS in Windows Server 2025 so special? Let's break down the three big powerhouse characteristics that really set it apart. First up, and this might be the most important one, is resilience. REFS is designed from its very core to actively protect your data from something called bit rot. It's this nasty silent killer of data where tiny random bits of data just flip on a storage drive over time, and that leads to silent corruption you might not notice for months. Now, what is so cool about this is just how proactive REFS is. It uses checksums, think of them like digital fingerprints for your data, to constantly check if everything's okay. And when it finds a fingerprint that doesn't match, especially when you pair it with a technology like storage spaces that keeps redundant copies, it doesn't just raise an alarm. No, it automatically repairs the corruption with a good copy, and it does this live without ever taking your storage offline. It's literally a self-healing system, which is just incredible. Okay, next up is scale. And I'm not kidding, the numbers we're about to see are just, they're staggering. And they really show how future-proof this system is designed to be. Yep, you're seeing that right. 35 petabytes. REFS supports a theoretical maximum volume size of 35 petabytes. Just let that sink in for a second. That is 35,000 terabytes. And this slide, wow. It just lays it all out, doesn't it? We are not talking about a small step up here. This is a quantum leap. That 35 petabyte REFS volume is over 135 times larger than the maximum you can get with a standard NTFS volume. I mean, this is built for scales of data that were just pure science fiction a few years ago. But here's the thing, it is not just about being huge. The 2025 version of REFS is built for today's hardware. It's got optimizations for lightning-fast NVMe storage. That's the new standard for ultra-fast SSDs. It also has a completely rebuilt deduplication engine to save a ton of space, a brand new Dev Drive feature to make developers' lives easier, and it even supports booting high-security confidential VMs. Okay, this all sounds amazing, right? But where do you actually use this thing? It is so important to know that REFS is a specialized tool. It's not designed, not yet anyway, to be a one-size-fits-all replacement for NTFS. So let's break it down. Here are the top 4 sweet spots where REFS just absolutely excels. Think about anything that involves massive, performance-sensitive, and mission-critical data. So it's perfect for storing your Hyper-V virtual machines, it's great as a repository for large-scale backup systems like Veeam, and it is the default choice for building huge resilient storage clusters. And of course, that new Dev Drive feature makes it a total win for developer workstations. Now, let's be real for a second. To give you the complete picture, it's absolutely essential to understand that REFS isn't a silver bullet. It's not perfect. It comes with its own set of trade-offs and things you need to consider. This table gives us a really nice balanced view. On the one hand, its strengths in data integrity and massive scalability are just unmatched. But on the other hand, you can see it's not meant to replace NTFS as the boot drive on your regular servers. It also doesn't have some of those older NTFS features like file-level encryption, and you're going to want to keep an eye on CPU and RAM usage, because some builds have shown it can be a bit resource-intensive.
So, what's the bottom line here? What should you really take away from all this? The best way to think about RIFS is as a high-performance, high-capacity specialist in your storage toolkit. When you need that resilience, scale, and speed for things like VMs or those huge backups, it is the clear winner. Just, and this is key, remember to test it and monitor its performance for your specific workload. And that leaves us with one last big provocative thought. With these undeniable advantages for the most demanding modern workloads, are we actually seeing the beginning of the end for NTFS in the data center? Is this the moment the torch really begins to be passed?